Okay, so the most efficient way to graph when you're given a line in these forms. What I like to do, your point is x1, y1, right? You've got that point. So you graph your point. And then you can use the slope to find a second point because you've got a rise and a run. So you can start at your point and go up or down the amount of the numerator and then across the amount in the denominator. And we're gonna practice that. Okay. Same thing with this, but here you're going to start at your y-intercept. So you graph a point, and then you use your slope to find your second point. And 2 points make a line. So you can then, in both of these cases, draw a line. Okay, now we take a little different approach when we have it in standard form. Do you remember finding x and y intercepts in Algebra 1? If you set the y equal to 0, that's your x-intercept, and you can cover it up. It's the same thing as setting it equal to 0. If you set the x equal to 0, that gives you your y-intercept, and we'll practice that too. So that's actually my favorite way to graph because it's so fast. Okay. So we're going to graph these equations. Now, when you're doing your graphs at home, have you ever seen foodplot.com? It's fabulous. Now you have to put your equation in slope-intercept form, or at least you have to have the y on the left, because it gives you y equals, and then you type in the rest, and it plots it for you. So that way you can do your homework and plot your graphs, and then you can go check to make sure you got them right. I love foodplot. Okay, so that's a fabulous tool to check your graphs. So graphing when you have point-slope form. So what we said is we're going to graph our point. Well, our point is 1, -2. Remember, the signs are the opposite. And our slope, so here, x1, y1 equals. And our slope is 1/3. So on our graph, I'm going to graph the point 1, -2. So 1 in the x direction, -2. So there's my point. Nice big point. That's a little crazy big. I don't think I have a big ruler to use here. But then my slope tells me rise is 1, so I can go up 1 and over 3, okay, plus 1 plus 3 to get to my second point. And then I'm just going to sketch a line. It's probably not very accurate, but you can use a ruler. You can also use, if you have an ID card or something, you could use that. It's not a very straight line, but 2 points determine a line, so you can draw that. Okay, so find a point. You've got a point here, and use your slope. Now same here, we have a point. This is our y-intercept. That's where it crosses the y-axis. Okay, so it crosses the y-axis at -1. That's why it's called the y-intercept. And then we can go up 2 and over 5 to find our second point. So up 2, 1, 2, 3, 4, 5. There's our second point. And then we can draw a nice, not straight line through those points. Boy, those are bad. This is the one where we're graphing the intercepts by setting x and y equal to 0. And that's going to give us 2 points. One's going to be the y-intercept, one's going to be the x-intercept. Okay, so to get the x-intercept, well, the x-intercept, if you look at the x-axis, all along the x-axis, y is equal to 0. Because this is the y direction. So y is always 0 here. So if we set y equal to 0 in our equation, then we find out what the x-intercept is, where the graph crosses the x-axis. So then this gives us 4x equals 8, so x equals 2. Now what I was showing you a minute ago is a much faster way to do that. Setting y to 0 is like making this whole thing disappear, and then you can see x equals 2. Okay? And so, x equals 2. Remember to put it on the x-axis. Okay? Similarly, if I set x equal to 0, remember the negative is part of the 2y, the negative 2y. So what's y? Negative 4. So I'm going to put that 1, 2, 3, 4 on the y-axis. Then there's my line. I would love to have done, that one's a little straighter. Write the equations of horizontal and vertical lines that pass through this point. So first, let's plot our point. And it'd be better to do this on graph paper. So this is negative 2, 5. And here's the horizontal line, okay? And here's the vertical line that goes through negative 2, 5. What is the equation of this? Well, a very easy way to see that without, because it's very easy to get mixed up and forget if it's x equals something or y equals something. These are your two equations for horizontal and vertical lines. Plot 3 points. Do 1, 2, and 3. Here's x equals 1, 2, and 3. So if you look at those points, the points are, here's x, 1, 2, 3. What's y in all of those? 5. 5. 5. 5. Oh, then you can really see that the equation has to be y equals 5. It doesn't matter what x is. So y equals 5 is my horizontal line. It's easy to get these mixed up because you think of y as the vertical axis, but y equals 5 is a horizontal line. Now similarly, I could plot points at y equals 1, 2, and 3 on this line. This is my vertical line. Okay, so y equals 1, 2, and 3. So, and x in every case is negative 2. Well, x is stuck at negative 2, right? So this is the equation for my vertical line. X is negative 2. It's stuck. It doesn't matter what y is. Y is irrelevant. Y can be anything. That's why it's not mentioned in this equation. Okay? And you can go the other direction too. You're given the equation for, or you're given this, you can create a little chart like this and graph your line to determine whether it's vertical or horizontal. All right.